Alright guys, woo! Functions part 2. So we want to be able to write a function rule, and we need to be able to recognize a pattern to do so. So here, writing function rules, looking for the pattern. What would stage 4 look like? So we've got a 1 puff of smoke, 2 puffs, 3 puffs. So stage 4 would be another puff of smoke. So 4 smokes, I guess. What would stage 10 look like? Well, after 10 stages, it'd be 10 puffs, so 10 smoke. Billows. Create an input-output table and write a function, or write an equation to represent the function. So our input would be 1, 2, 3, 4, and so on. And our output would be 1, 2, 3, 4. So that's a pretty easy function. That is, our outputs are y, or f of x, and our inputs would just be x. So the output is the same as the input. So f of x equals x, or y equals x. So these are the same. This and this are the same. Alright, so one butterfly takes 7 blocks. 1, 2, 3, 4, 5, 6, 7. 2 butterflies is going to be 7 plus 7, that's 14 blocks. 3 butterflies is going to be 21 blocks. So create an input-output table. That would just be 1 butterfly, 2, 3, and they don't have to go horizontal. They could go vertical as well. 7, 14, 21, and write an equation. So here our equation is if y is the number of blocks and x is the number of butterflies, it's y equals 7x, because there's 7 blocks per butterfly. So you could write this, or f of x equals 7x. Alright, so those are a couple of easy ones. Let's look at another one here. Patty the plant. It says, month 1, got 5 leaves. 2 months, there's 6 leaves, 7, 8, 9. So the pattern would be 5 months, 9 leaves, 6 months, 10 leaves. Write an equation. So here, basically what we do to write an equation is we want to notice the change. So this is the common difference, we call this. And that is, we go up by 1 for every 1 we go up here. Right? So when these are counting up by 1s, the inputs are all counting up by 1s. Figure out your common difference. Alright? And that would be a 1. So your function is always going to be y equals the common difference times x plus your 0 number. Alright, so the 0 number is, let's say we continue this pattern backwards once, what would our 0 number be? So like if our input was 0, then our output would be a 4 if we continue the pattern backwards. So here our function is y equals 1 times x plus 4. Alright, there's our function. Test it, make sure that does that work. If we plug in a 1, 1 times 1 is 1, plus 4 is 5. Let's try another one, 4 here. Let's test this. Plug in a 4. 1 times 4 is 4, plus 4 is 8, so it works. Alright, now we could find, 200 months later, how many leaves does it have, theoretically. So if you're already given a table, come up with a function. So we already have our 0 number, right? So that's a 2. Our 0 number here is 0. Now these are going up by 1s, 1, 2, 3, 4, 5. So then here's our common difference, plus 1 each time. So our function rule is going to be y equals the common difference times x plus our 0 number. Alright, so here our common difference is 1 every time. So we have y equals 1 times x plus our 0 number is a 2. So the 0 number just tells you where to start, And this common difference tells you how much you go up by each time. So then that could just be written as y equals x plus 2. That's fine as well. Now here, what do you notice different about the input or the domain? See, they go up by 2's every time. That won't allow us to directly get our common difference. Our common difference is found when the x's or the inputs go up by 1 every time. Then we find what jump or what number do we need to add or to subtract to get all our outputs. So here we have to imagine that there's a number in between that, 0, 1, 2, 3, 4, 5, and so on. So now if we went 0, 1, 2, 3, like we're doing here, 0, 1, 2, 3, what would these in-between numbers have to be? Well, since you go up by 2 here, and you go up by 1 there, halfway between 0 and 2 is 1. Halfway between these is a 0.5. So now if we go up 1, 2, 0.51. So 2, 3, 4, 1, 1.5, 2. So now we have our pattern with our x's going up by 1's. So we have our 0 number, which just happens to be a 0 this time, and our common difference. So here's our 0 number, and here's our common difference, is a 0.5. So we have to add 0.5 each time. So that would be y equals 0.5 times x plus 0, which I would just write as y equals 0.5x. If you're unsure, test a few random inputs. Let's test this one. If I plug in an 8, 0.5 times 8 gives me a 4, so that works. And if I test any of the other ones, it'll work too. All right. So if you're given a function instead, can you come up with a table? So this is just the reverse. Instead of having a table and getting the function, we have the function, we're getting the table. This is even easier. So use the values 1, 2, 3, and 4 as your domain. So domain is input. So that's 1, 2, 3, 4. And then our output also is the range. Remember, those words are synonymous. So we're plugging these into here. So this is like y equals negative 2x plus 8. So that would be negative 2 times 1 plus 8 is 6. Negative 2 times 2 plus 8 is 4. Also notice that our common difference here is a negative 2. So we're going to go down by 2's each time. So if I do it out, negative 2 times 3 plus 8, that's negative 6 plus 8 equals 2. But the common difference tells us we're going down by 2 every time, so I should have just known to go down by 2 to 2, 0. Alright, so graph that. Over 1 up 6, over 2 up 4, over 3 up 2, over 4 up 0. Right, so our y's are, every time we go over 1 on our x, our y's are going down by 2. So over 1, down 2. So here, our function is just a little bit different. It's got a fraction. So I'm just going to pretend this is like y equals, sort of simplify that there. It's the same idea. Now, our inputs are all divisible by 3. So that makes multiplying the fraction just that much easier. So if I do 2/3 times 6 minus 5, when I multiply fractions, I want them both to be fractions, so that's like a 6 over 1 is equivalent. So that gives me 12 over 3 minus 5. 12 over 3 is the same as 4. 12 divided by 3 is 4, minus 5 equals negative 1. Okay. Try the next one. 9. So 2/3 times 9 minus 5. So you can compute this out and get 18 over 3 minus 5. That gives you 6 minus 5 equals 1. What I would typically do, hopefully you guys know this, is just reduce the fractions. So 9 over 1 and 2 over 3 can reduce out the 3's. 3 goes into 3 once, 3 goes into 9 3 times, and that would give me 2 times 3, 6 minus 5 equals 1. That's the easier way to do it. And then now we can continue our pattern. Since we're going up by the same amount, even though it's not 1s, we're going up by 3, 3, 3. This will change by the same amount each time. So plus 2, and plus 2. Alright, let's just double check and make sure. 2/3 times 12 minus 5 is 24 over 3 minus 5 equals 8 minus 5 equals 3. And if you check the fourth one is in fact a 5 as well. Alright, so we can't actually fit on our graph here, but I'm just going to make these go up by 3s. There we go. Fixed it. Now it'll fit. 3, 6, 9, 12, 15, 18, and so on. And then these can go up by just 1. So I just changed my scale. And that's fine to do as long as you mark the axis, so you indicate that you've changed your scale. And that's a -1. That's all right. We can ballpark that guy. So then we've got 6, -1. So that'll be down here approximately. 9, 1. 12, 3. And 15, 5. There we go. Alright, so here's your U-try for that concept. Alright, so have a good day, and I'll see you next class. Don't forget to also watch the applications video.